I'll start talking about friction force. Yesterday I talked about that. If we have an object, a box, in general, the friction force is zero, but it is not zero. For any object, if we magnify the edges and the contacting surfaces, they are not smooth. They are not easy to move. Okay, they are not smooth. Because of that, we have a friction force. From where this friction force comes? Yesterday also I talked about the nature of this material and that material, and there is an interaction between these not smooth edges. And if we apply a force, I will start an experiment with you, and you will do, I think, the same like this experiment in the lab. This is the force. This is the frictional force. This is the applied force. If I start my force by zero, this is zero. I am telling you from before, I told you from before that we have friction force, statistical and kinetic. They will start acting one by one. Look at this. If I have with a stationary object, we don't have any kinetic friction force. Now we have stationary. With zero force, I have zero frictional force. I have this point. If I increase it by 1, for example, it will not start moving. It will the frictional force will be 1. So this is 1, 1. For example, if I put it 1.5, this will be 1.5. 2, it will be 2. 4 will be 4. So this is 1. This is 2. This is 4. But this will not continue to infinity. I have a point. After this point, the object will start moving. Let us do it with the monitor. Okay. I will do it with the monitor. Now I'm applying a force. It is not moving. I'm increasing my force. It is stop. It is starting moving after maybe more force, which is assume my maximum force is 6. So the frictional force stationary will be 6. But if I give it a little bit, which is 6 point, for example, 0.1 or 6 0.1, then the stationary frictional force will not be enough to stop the object. The object will start moving. And I have another one, another frictional force, which is Fk, F kinetic. And this F kinetic will be smaller than the maximum. I have a maximum frictional force stationary. This is 6, for example, Fs max. But, and you can see that I have this line for the stationary object. But after just 6.1, for example, the object will start moving and the frictional force will be the Fk. It will be also smaller than the maximum value of the F stationary. So in this stage, I have F kinetic. Here, I have F stationary. And the kinetic friction force is smaller than the maximum value. Okay? And you can know that if you start pushing a box, it is difficult to start pushing it. But after the box starts sliding, it is simpler to push it. You can try that. I think you know, you tried that from before. Okay. For this box, I'll put an example here. Assume now we have this mass, which is M1. It has its weight 1. Because of that, it has a normal force, N1. If I need to push this mass, I need a force to start moving. What if I put another mass on the top of it? So I have also M2. So I have another W2. Also, I have another N2. They are bigger than before. Do I need more force to push or less force to push? It's simple. If I need to push this monitor, it's a mass. It's difficult, okay? But if I put another thing on the top of it, it will be more difficult to push. Why? Look, if the surface has no frictional force at all, the frictional force is 0, then it's the same. I can push a car or that eraser by the same force because I don't have any frictional force. But because we have a frictional force in our life, the mass and the weight and the normal force matter now. How can we know that? I'll tell you how. Now we need to know from this that the frictional force, the kinetic frictional force, is less than F station frictional force maximum. And the frictional force in general, it is always less than the maximum one. Okay. What about the frictional force in the kinetic state when we are moving? This will be equal to something constant. The frictional force in general, it is equal to some constant multiplied by the normal force. The normal force, it is equal to the weight downward, as we said yesterday. If we increase the weight, then the normal force is also will increase, right? Without this, yes or not? The answer is yes. So the frictional force will depend or depends on the weight. Because of that, if you put more mass, you need more force to push. What is the mu? This is a mu. No, not in Arabic. Mu. Mu is a constant. And this constant, tell me how the interaction between, or what like the interaction between two objects. For example, if I have glass interact with the plastic, is it the same as rubber with plastic? Is it the same? The answer is not. Because of that, we have this constant, which is different from material to another material. These constants in physics, we can't see them too much. For example, we just talk about one of them, which is G. Earth has its G, which is 9.8. Moon has its G, which is the 6th of the Earth. The sun has its G. It's a constant. Reflect the properties of that object or that system. Also, mu, it's a constant number. Reflect the nature of the interaction between these two surfaces. Glass with plastic, rubber with plastic, wood with plastic, and so on. You will see that in the lab. Also, you can see here in that page, which is there is number 2 down there. Just next to the example, there is a table. We have 2 frictional force. One of them is stationary, one of them is kinetic. Because of that, we have 2 mu's. One of them is stationary, one of them is kinetic. So Fs is equal to mu s multiplied by the normal force, or Fk is equal to mu k multiplied by the normal force. You can see mu k and mu s. Always mu k is smaller, as you see here. Mu k is smaller than mu s. Mu s here will give me Fx maximum. The maximum frictional force here given by that one. Not for all of the frictional force. Look, the interaction between steel and steel, it is 0.74, but mu k, it is 0.57. What about copper and steel, brass on steel, zinc on but I need to see rubber or something like that. Copper or cast iron, 1.05 mu s, but mu k is 0.29. Mu k is smaller. This is an example. I will solve this example now. This example, we have a box, a block of steel, I think. Yes. On a cover. Okay. 2 surfaces. What is the mass? The mass is 5 kilograms. As you see now, every time we deal with mass, we need to know what is the mass, because do you know what? The equations of motion, P2 equal to V1 plus AT and so on, these equations are found by Galileo Galilei. That Newton's come or came, and he put this law, F is equal to ma. The acceleration from the equations. But he used the mass. Because of that, he gave us a new level. Okay, now we are dealing with the mass. Yesterday I talked about the mass. We have a force. What is the least applied force to make from start? Yes. If I apply the force F, if my force to the right, then the frictional force to the left. So this is the frictional force. We have 2 surfaces, steel with copper. Steel with copper. Where is the copper on steel or steel copper? It's the same. Mu s from the table is equal to 0.51. Mu k is equal to 0.44 without units. the least force to make the object start moving? The object is stationary, so I need to use the stationary method. So F stationary. I'll do it like this. I need to put a force. This force I need it to be equal to the frictional force maximum. After that, it will start moving. So this will be equal to F S maximum, which is equal to mu S multiplied by the normal force. What is the normal force? Who can tell me? It is simple. The normal force upward should be equal to the weight downward. Because our surface is horizontal, you will see in the lab. Also, in other examples, maybe the normal force is normal to the surface, it is not to the opposite y. The weight, it is the mass multiplied by g. The mass is 5 g. So this is equal to the normal force. Simply, normal force is 5g, but to the positive y direction. Mu s is given. So my lowest force need to be to start moving. It is mu s, which is 0.51 multiplied by the normal force, which is mg. M is 5, g is 9.8. Then my answer should be equal to 25. Yes. 25 point something. 7 newtons. Now my object start moving. Okay. What if I ask you to give me another force? This force is to keep the motion of this object with constant velocity. Velocity means the acceleration is equal to 0. Now the object starts moving, but I need to continue moving without acceleration. So I need, without acceleration, I have the force to this direction, the applied force, and this is the frictional force. Now the object is moving. So this is the kinetic frictional force. Because the acceleration is equal to 0, from Newton's law, the summation of F, we are on X, just on X, it's okay, is equal to MA, should be equal to 0 because the acceleration is 0. What are the forces? I have F applied plus the frictional force should be equal to 0. What is the applied force? I need to find. Should be equal to the opposite side with negative side. The frictional force to the left direction. What is equal to? It is equal to mu k multiplied by the normal force, which is equal to mu k 0.44. And is mg, which is 5, 9.8. This will be equal to 17 point something newtons, right? 17.64 newtons. Right. Compare between these two forces, you will see that the force required to start moving is too much larger than the force to keep that moving. The same velocity. Any question about this?